fairly straightforward, but it provides network protection between a trusted network and an untrusted network. Using a firewall is strongly recommended to be implemented into any network that connects into the internet. Next we have next generation and UTM. So firewalls over the years have evolved to include additional security protection. Firewalls typically in the past dealt with allowing or restricting traffic based on IP addresses and TCP or UDP ports. Next generation firewalls are now including security for inspecting applications like web traffic to antivirus or anti-spam protection. The term next generation is often used for medium and large size firewall products like the Cisco ASA, the Fortinet, or the Palo Alto Networks firewall model. UTM is often referenced with small business firewalls like SonicWall, but it is the same definition either way. Trust and untrust. A trusted network is the network we want to protect from other networks we're not sure about. This would be the internal or inside network where our servers and desktops exist. The untrusted network is basically the internet or any network that we are unsure about in terms of its security. And we need to protect our trusted network from the untrusted network. Next we have policy. A policy is configured on the firewall which describes a particular action based on certain information. An example of a firewall policy will be something that will only allow access to a web server using TCP port 80. Next we have content security. Content security deals with advanced level of security that is next generation or UTM, dealing with antivirus, file blocking to URL filtering. IPS in some sense can also be considered as content security as well. Active and standby. So this deals with the redundancy or the failover of a firewall appliance. A firewall appliance can be configured with two firewall devices to provide redundancy, where one firewall is active, which is considered as the primary unit where all traffic is routed through, including any security enforcement. The other firewall is in standby mode, the secondary firewall, doing nothing but collecting details from the primary firewall and ready to take over if the primary firewall fails. Next we have translations and NAT. Now translations deals with translating one IP address to another IP address using a protocol called NAT. NAT has become a critical protocol for many years, avoiding the need to migrate from IPv4 to IPv6. Without NAT, we will quickly run out of IP addresses on the internet. With NAT, we can translate all private IP addresses on the internal network to one or maybe two public IP addresses assigned to us, thus saving the need to obtain multiple public IP addresses and potentially saving money that way. Next we have application inspection. Now application inspection is part of the next generation services for firewalls, including content security. Basic firewalls would only block or allow traffic based on IP addresses or ports for TCP and UDP data. Application inspection deals with looking at the contents of the data payload in an IP packet to determine if there are any security risk with the traffic that could be compromised or could compromise the system or the entire network itself. Next we have stateful firewalls. So most firewalls today are all stateful firewalls and no additional configuration is required to make a firewall stateful unless you are enabling firewall services on a router device. A stateful firewall does the following by default. First, any traffic that is initiated from the internet or an untrusted network is not allowed into the network because we do not trust the intentions of what hosts on the internet are doing. And second, any traffic initiated from the inside or trusted network, that traffic will be allowed back in since we trust what our internal network is doing. Next we have split tunnel. Split tunnel is a term that is used with client-based VPN solutions like IPsec or SSL VPN. So split tunnel deals with specifying what traffic should be routed across the VPN tunnel. Here's an example. If you're accessing your company's application system, well, that should be routed through your VPN tunnel. If you're accessing your Facebook page, that should not use the VPN tunnel. So this is how split tunneling can be used. And next we have a data flow or traffic flow. And this is just the conversation that travels through the firewall containing details such as the source IP, the destination IP, protocols, ports, and application data within the payload of a packet. The flow is what the firewalls are looking at and expecting to either block or allow into another network. Next, let's talk about firewalls a little bit further. So there are many firewall security vendors that provide a firewall solution for network security. These are some of the following. Some can include Cisco, SonicWall, Juniper, to even a new player in the market called Palo Alto Networks. Now, all of these are great working firewall products. Many may criticize these firewalls in terms of lack of performance or security functionality, but that is not the case. It's a matter of how these firewalls are deployed correctly into the network with best practices in mind, to choosing the right model that aligns with the business size of the environment. So for example, the Cisco ASA and Juniper firewalls are commonly deployed for larger size networks, where the SonicWall is commonly deployed for small and SMB networks, including the smaller end Cisco ASA 5505 unit. This series is focused on Cisco firewalls using the Cisco ASA firewall, but let's step back and discuss the different firewall options using Cisco products. Cisco firewall services can be deployed with a dedicated firewall appliance. This would be the Cisco PIX or ASA appliances. For larger networks, using a Cisco Catalyst 6500 series switch, they can use a firewall services module like the FWSM or the ACE module for robust performance and integration within the switching chassis. Or a Cisco firewall can be configured as a service on an existing Cisco device like a Cisco router. Now this is definitely my favorite option for firewall configuration that keeps a nice and simple deployment. We can configure either reflective ACLs or CBAC or CBAC to provide a stateful firewall within a Cisco Internet Edge router. Our workbook solution document within this package shows how to deploy these Cisco iOS firewall services on the network. Now the PIX firewall appliance is old stuff. I remember working with these firewall products and they work great. They have evolved a lot and I like the configuration structure of these appliances. The Cisco PIX firewall was often teased by other security folks to be a fancy ACL router acting as a firewall, but its performance and configuration structure changed all that speculation in short time. The Cisco PIX had many different models, from the 501 series, which was restricted based on the number of users, to the 535 model. The PIX model will vary based on the performance and interface cards needed for additional networks. The PIX firewall is end of sale and end of life, meaning this is a legacy firewall that should no longer be used. However, it is still used in many networks today because they're still reliable, providing the security that is needed. The PIX firewalls provide basic network security of a stateful firewall and IPsec VPN support for clients and for sites. There are also some basic application inspection using what was called fix-ups. The Cisco ASA 5500 series is considered as the next generation firewall series evolved from the PIX models. There are more models released for the ASA firewalls even to this very day to support high performance firewall throughput of 10 gigabits per second, even higher. The firewall models will range from the 5505 series, which is aimed for small business networks, to the 5585, which is aimed for large data center networks. The Cisco ASA compared to the PIX provides more security services, which includes some of the following: stateful firewall protection, IPsec VPNs for clients and locations. SSL VPNs are now included for remote access for clients. Application inspection using MQC, which is similar to the QoS configuration on Cisco routers and Cisco switches today. The ASA firewalls now allow support to virtualize multiple firewalls on the same physical appliance using something that is called security contexts. Well, in all fairness, the Cisco PIX using OS version 7 was able to do security contexts as well. The ASA could be configured in routed mode or even transparent mode. We will discuss further with what that means. The Cisco ASA, through the use of the security modules, could support content security such as anti-spam, antivirus, URL filtering, and more. And basic to advanced IPS services on the ASA with high level performance. There are some software and licensing aspects which are important when dealing with the Cisco ASA firewall. First, there is the operating system of the Cisco ASA, which started with version 7, and now we're using version 8. Version 8.4 is one of the latest OS releases, which is a little different based on how things are configured, such as NAT. Our video series will focus on using this latest OS release. The ASA model may include a base bundle or a Security Plus bundle. Now, the Security Plus bundle provides support for firewall failover to the number of VLANs supported on the unit. As for administration, the ASA can be managed using either the CLI or a GUI interface called the ASDM. We'll discuss this further in a separate slide. The ASA does have other licensing aspects depending on what services are used. If you're using the Cisco ASA 5505 model, there are licensing based on the number of users. This can be 10 users or even 50 users. There's also a version for unlimited users, but the cost will vary based on the number of users that are needed, so just keep that in mind. The ASA firewalls can support up to a number of VPN sessions depending on the model that is used. Using SSL VPN requires additional licensing for a number of concurrent users, and we will discuss that further and what we recommend later on in this presentation. There's other licensing involved that is recurring, such as IPS and content security services. It's a recurring subscription fee because these services are signatures or updates with new security attack info that should be looked at and protected against. Just keep in mind that all IPS and content security products, not just Cisco, are usually subscription based. From everything that is listed here, it's important to understand that buying just the firewall itself may come with additional costs if you want additional services like advanced IP services to supporting a large set of SSL VPN users. As we mentioned before, with the release of 8.4 and higher, there are changes to NAT with its terminology and how it is configured. Now, I honestly liked how NAT was configured before in the past, where the new structure provides an unneeded and complex configuration for NAT. So it's important to understand this new structure, especially if you'll be working with an ASA running version 8.4. Now, it's not that difficult or challenging. So the purpose of our video series is to show you how to configure NAT on this new operating system. Now, with the new way of configuring NAT in its basic form, you need to configure something called network objects. Now, these are objects that list either an host IP address, a subnet, or even a range of IP addresses. Within those objects, we can easily define how it will use NAT. NAT rules, or twice NAT, can be used for more unique translations or further port redirection to a single host. Twice NAT provides some pretty complex but advanced NAT scenarios that can exist. Configuration-wise, it is called NAT rules, and we will show you how to add a NAT rule on the ASA firewall using the ASDM interface. Here's an example for what twice NAT could provide users with advanced and unique requirements with different or various types of communications. So we have a computer using the IP address of 10.1.2.27 that exists on the inside network. If the computer connects to the web server on the internet, it will use the public IP of 209.165.202.129. However, if that same computer tries to access the same web server on port 23, the telnet application, it will use a completely different public IP, which would be 209.165.202.130. This is how twice NAT can be used and configured on the ASA firewall. So, when should you use network objects and twice NAT in practical deployments? So here's the breakdown for what to consider and what we will actually use for our NAT configuration in the video labs. Configuring network objects is a very simplified configuration over NAT rules, so you will very quickly see that. However, configure network objects if you want to do the following. First, if you are configuring paths for an internal subnet that will NAT to a dedicated IP or the WAN-facing IP on the ASA firewall. Or if you are configuring a one-to-one NAT translation between a private host and a dedicated public IP address. Or if you want to configure a simple port redirect to a server. This means a single TCP or UDP port can be redirected between our server and the public IP address on the WAN interface, but not forwarding multiple ports to a single server. This is where using NAT rules come in, but it's more complicated to configure. So use NAT rules if you want to configure port redirect that can forward multiple ports to a single server using, let's say, the WAN IP address on the ASA firewall. Again, this is what we will configure in our video labs. Next, let's talk about the Cisco ASA components and the different firewall modes. The Cisco ASA has many components which are good to discuss. The ASA firewalls, whether it is the 5505 or the 5510 model, will obviously Ethernet ports used for the different security zones and for failover purposes. The Cisco ASA 5510 model and higher will have a management port, which is ideal for managing the Cisco ASA unit for its configuration and other tasks. Another component is the console port. The console port is used for initially accessing the ASA firewall for CLI configuration to advanced troubleshooting if you can't access the GUI interface for the firewall. The flash memory is basically where the ASA files are located. These files include the OS image, the ASDM software packages, and the AnyConnect SSL VPN client packages. For the Cisco ASA 5505 model, the flash is internal to the firewall itself. The other models, such as the 5510, can use a flash card inserted directly into the firewall unit. Another component is the security expansion slot, located on the far left of the ASA units. The security expansion slot are used for the security cards or modules dedicated for IPS or content security services like antivirus and URL filtering. The security modules for the Cisco ASA, which goes into the available expansion slot, provides the content security or IPS services that are required. So it will vary based on the model that you get and the security services that are supported, so definitely keep that in mind. So first, we have an SSC or the Security Services Card, which is only supported on the Cisco ASA 5505 model. These security cards only support IPS services with no support for content security, unfortunately. Now I do hope this changes since the ASA 5505 model, which is geared for small and SMB networks, they could benefit from those type of services. And second, we have an SSM or a Security Services module that is supported in the 5510, the 5520, and the 5540 models. They provide either IPS or content security services. The Cisco ASA 5580 and the 5585 models are aimed for larger networks and data centers with high-end performance requirements. Either way, the configuration, whether it is a 5505 or the high-end 5585, it doesn't really change much, so just keep that in mind. For this high-end ASA model series, the security modules is called the Security Services Processors, or the SSP, which resembles more of a line module that fits into the firewall chassis. The SSP only supports IPS services and is typically not ideal for most enterprise campus networks that could use content security. So the Cisco ASA firewalls can operate in either a routed mode or a transparent mode, not both. Now by default, it operates in routed mode. Now the routed mode is the most common firewall deployment since the very beginning of time for firewalls, really, and it's still used today. And basically each interface is configured with an IP address enabled for routing within the ASA firewall. Transparent mode is usually deployed for unique environments who want to quickly add firewall services between other networks seamlessly. It basically operates in a bridge or layer 2 mode. Next, let's dive into some of the features on the Cisco ASA and explain some of these concepts further. So the Cisco ASA firewall, along with the PIX firewall, supports the use of VLANs in 802.1q, also called VLAN tagging. This type of deployment is strongly recommended and is becoming a common configuration than using multiple interfaces on the firewall unit. With VLAN and 802.1q, we can extend VLAN tags to the ASA by creating sub-interfaces, or just a VLAN interface if it is the ASA 5505 unit. So for example, we may have a guest network on our LAN configured as a VLAN. That VLAN can be extended up to the ASA firewall for its default gateway and security zone. Now the number of VLAN tags supported will be based on the licensing bundle and the firewall model that is used. So for example, the Cisco ASA 5505 can support up to about 20 VLANs trunked if it is the 5505 model with the Security Plus bundle. For the 5510 to the 5550, for example, they can support up to between 50 to 250 VLANs. The Cisco ASA firewall support VPN tunnels, whether they are site-based or client-based. So a site-based VPN is also called a LAN-to-LAN, which builds a secure tunnel between two locations over the internet, or even across a private network if that is required. No client VPN software is needed, where the VPN tunnel is really seen as a private connection between sites. The VPN tunnel uses IPsec or IKE version 1 for the VPN termination, but it can also use the latest VPN protocol, which is IKE version 2 on OS version 8.4. When configuring site-based VPN tunnels through the ASDM, it is strongly recommended to use the VPN wizards, which is what we'll be doing in our video labs. Client-based VPNs is a remote access solution that allows users to access network resources remotely. So we have a few options here. We can use IPsec or SSL VPN, even both if needed. Now, this requires a VPN program to be installed on a user's machine. If using IPsec, then the Cisco VPN program needs to be installed before connecting and requires to set up a profile. Now, this program now supports 64-bit machines, which was not recently possible. So that's a very good thing. If you're using the SSL VPN solution, then the Cisco AnyConnect client needs to be installed, but it can be installed automatically once you log in and no profile is needed beforehand. The AnyConnect solution can further be deployed in either a clientless mode or a tunnel mode. Now, clientless mode is all web-based with some port forwarding. Now, tunnel mode is the most commonly used and basically requires the AnyConnect client software to be installed. For user authentication, the user can log on using local accounts that are created on the ASA firewall, or using their AD credentials if Radius or LDAP is integrated between the ASA and an Active Directory environment. For remote access, using SSL VPN, you can use the Cisco AnyConnect VPN client app on Apple's iPhone for connecting to the ASA to access resources remotely. So this is a free app you can download and install from the App Store. But there are some requirements that many don't initially understand before using this app, and they get a little upset. So I definitely want to communicate that now. It requires two things on the ASA before users can use the AnyConnect app on the iPhone. First, it requires the AnyConnect Premium license to be installed on the ASA firewall. We're not sure if it will support the AnyConnect Essentials, but definitely the AnyConnect Premium. So this definitely is an error here in this slide here. So make sure that you're using the AnyConnect Premium license on the ASA firewall. So purchasing, basically, let's say the licensing can definitely vary though. It can be around 120 bucks, a little bit higher, so it all depends. But second, it requires the AnyConnect mobile license to be installed on the ASA firewall. So without these two requirements, The app will not work on the iPhones. Just keep that in mind. Both are required. The AnyConnect Premium license and the AnyConnect Mobile license. Now, here's my 2 cents on the whole thing about this and about the two different remote access solutions of IPsec and SSL VPN. So between the IPsec client and the AnyConnect client, I recommend using the Cisco IPsec VPN as a remote access solution. The bottom line is that it works and provides the same functionality, which is remote access to network resources. Now, there are other reasons. For one, the Cisco VPN client is already built in with the iPhone, so no additional install is required, not like it was an issue before. Second, no additional licensing is required. So purchasing a Cisco ASA 5510 by default for most of its models will support up to more VPN peers compared to the SSL VPN peers. This can be used for client or site-based connections. Using SSL VPN up to 250 users, for example, will result in additional licensing costs for the VPN user count and even for this mobility or this mobile license. None of that's required with IPsec. It's a better cost savings for a remote access solution. Now, you would notice many practical networks today that are still using IPsec over SSL mainly because of the cost. Now, companies that are using SSL VPN are typically larger or have higher security requirements, like not using a VPN program where everything has to be web-based. Or if large companies have money left over to spend in their budget at the end of the year, then purchasing the AnyConnect mobile license is possible. It's not that expensive, really. I remember taking part of that many times for the larger environments, like for the Department of Energy, though, that I worked in. Unfortunately, the money at the end of the year, that sort of thing, it's not really an option for small or SMB networks. So IPsec VPNs is still a great remote access solution to use. Using the security module on the Cisco ASA can support the following content security services, which are listed here, which includes things like antivirus, anti-spam, file blocking, and URL filtering. So a very big plus you can definitely do, and there's a lot of great reporting things as well. The URL filtering basically is using Trend Micro, so it's pretty expensive though, but it does provide a lot of good kind of content security kind of consolidated within your firewall infrastructure. The Cisco ASA firewall, starting with the 5510 model, not the 5505 model, can be virtualized into many firewalls. This is called security contexts, and the number of virtual firewalls that can be created is based on the number and support of security contexts on the ASA firewall. Using security contexts, we could create 3 virtual firewalls within one physical firewall. Each virtual firewall, for example, can be used for a dedicated client or network. We can even use VLANs and sub-interfaces to be divided out among these virtual firewalls. The PIX and the ASA firewall can support failover using 2 firewalls. For the Cisco ASA, it requires the Security Plus bundle, and 2 identical firewalls is required. So they must have the same operating system, the same VPN packages to the same security cards. The firewall configuration can either be active standby, which is the most common for environments. Now, this option overall is recommended to keep a very nice and simple implementation. Or you can set up an active redundancy type of configuration. We show each possible scenario here in these graphics. For the active standby option, traffic only routes through one of the firewalls, acting as the primary unit. But it does exchange firewall state information with the secondary firewall. But majority of the time, the secondary firewall will be idle, doing nothing. So implementing the active option, both firewalls are actively forwarding traffic and expecting. Now, this can present some challenges in terms of troubleshooting performance or other security related events for a particular data flow through the 2 firewalls. So just kind of keep that in mind. Your administration, your troubleshooting may kind of increase with the active model compared to the active standby model. Performance. So understanding the performance requirements between the different ASA firewalls is important. Depending on what services will be used, including the path data would travel. So for example, if the firewall is connected to the internet only, that means data can travel from the internet to the LAN and vice versa. So understanding the bandwidth that is used on the LAN and the internet is important. The lowest bandwidth should be considered for the firewall and IPS throughput. If the internet speed is 3 megabits per second for a DSL or a bundled T1 configuration, and the LAN is 100 megs or even 1 gig, then the lowest possible bandwidth or lowest possible throughput along this data path will be 3 megabits per second. Therefore, the firewall throughput needs to be at least, that's right, 3 megabits per second. The ASA has different performance metrics as shown here in the graphics, such as firewall, IPS, and VPN performance. If you're using a security module in the ASA, then the performance can further be offloaded and accelerated. So understand the data path through the ASA and understand the potential throughput, then align that information with the performance of the ASA model that is needed. But there is one point that must be considered in how to read these charts on Cisco's website or any vendor firewall webpage for that matter. Is when we deal with using multiple security services on the firewall. When we talk about performance, we see metrics on Cisco's website for the ASA firewall reflecting the following that is shown here. The most common misperception here is that most network engineers see this and interpret it the same way. Let's provide an example of this. For the ASA 5510, the firewall performance that is listed here is 300 megabits per second, and the VPN performance is listed as 170 megabits per second. You see it there. Now, network engineers assume this means that the firewall and VPN performance will use those metrics listed, but that's not true though. The performance metrics listed assumes that the ASA is operating fully as a firewall or as a VPN device, not both at full capacity. If this was a pure VPN device using the ASA firewall, then its performance is up to 170 megabits per second. But if the ASA will act as a pure firewall, then it would be up to 300 megabits per second. So using both services at full capacity would produce lower performance numbers, which may not be bad. The performance could range from 50 to maybe 100 megabits per second for both services running along the data path from the internet to the LAN, which could be 6 megabits per second, for example. That's not bad since the lowest possible throughput will be 6 megabits anyway. However, most environments today using firewall and VPN services are not using it at full capacity or close to those performance metrics. So you will never see any performance issues to begin with. But either or, it's important to understand how to use this information and for selecting the firewall products. Management. So the Cisco ASA firewall can be managed in two ways. First, it can be managed using the command line interface or CLI. You can use the console, the telnet, or SSH to administer the ASA firewall. This is my preference for configuration and management on ASA firewalls. Second, it can be managed through a GUI interface or application called the ASDM. This video series is focused on showing you how to configure the ASA firewall using only the ASDM tool for a practical firewall deployment. The ASDM application is very impressive and has greatly improved over the years. The ASDM application has a great dashboard that's present where you can actually view performance metrics, firewall sessions, drops, and other security-related events, including log messages. All great for easy and more convenient troubleshooting. You can also run a packet tracer, which allows you to specify the source IP, the destination IP, and even ports to determine how the particular packet will be handled through the ASA firewall, whether it will be dropped or maybe allowed. So this is great for confirming that the ASA is configured correctly. You can also run an actual packet capture on the ASDM and use a program like Wireshark to view the conversation you captured through the ASA for a particular conversation or flow through various networks. Our video series will show you how to use all of these tools through the ASDM interface. Using the ASDM for the ASA configuration, there are some things to consider for troubleshooting. First, any errors encountered for any of the configuration will show an error display and the details about it or what should be configured beforehand. So it'll be very useful. Use the wizards available within the ASDM for creating new sites or new client-based VPNs on the firewall appliance. It keeps it nice and simple. When you try to configure this manually, it's going to be a nightmare. So use the wizards, and we'll be doing this to kind of illustrate that. And there are many great troubleshooting tools that we talked about before, such as the packet tracer to even doing a packet capture for a data flow through the firewall. Along with what to look out for in terms of troubleshooting, here are some likes and dislikes about using the ASDM with the Cisco ASA for its configuration. Let's start with the likes or pros with using the ASDM application. First, the ASDM itself as an application has greatly improved over the years, especially with the GUI application that was used for the PIX, called the PIX Device Manager or PDM. That was really bad. So using the ASDM, we can configure, we can manage, and we can monitor many aspects of the network, which is fantastic. There are many great tools, such as the packet capture and even running a packet tracer. In the future, it will be really nice if the packets can be analyzed on the ASDM for further input for a particular traffic flow. So that'd be a nice to have. Through the ASDM, we can easily back up every aspect of our ASA. Not just the configuration, but even with the different software images or packages, the certificates, what's being customized, everything, including doing a restore with what has been backed up. And we'll show you that in one of our videos. The ASDM has many great wizards for VPN configuration, which is strongly recommended, and what we probably mentioned at least a couple of times, and what we will be doing again in our video labs. However, there are some dislikes or cons when using the ASDM that I have personally seen in the past, and some for you to definitely keep in mind when you watch these video series and try to use this for your own network for configuring your ASA using the ASDM interface. So, using the ASDM is really like a proxy or interface between the GUI representation of the ASA for its configuration and the CLI interface, where the configuration is translated to. So with that being said, and why I always prefer CLI over GUI, there have been a lot of strange anomalies that come up for some of this configuration. Strange even for very simple configuration. For example, I remember I tried to add or input an NTP server, but nothing happened. It didn't, like the changes did not even take. Closing the app and then relaunching it, doing the same steps for adding an NTP server, it worked. Unfortunately though, I never encountered those type of events using CLI. So these weird anomalies will kind of come up. It's rare, but they will come up from time to time. For the SSL VPN web portal customization, it can only be done through the ASDM. And at least with version 8.4, we have encountered many configuration errors with the ASDM. So this is probably the strongest dislike that I have when using the ASDM application. Another one is with threat detection. Wow. So threat detection is a feature that is enabled by default, which is fine. But enabling scanning for threat detection can be a nightmare. But if a host is suspected in doing a scan, even though it's not doing a scan, it will be blocked or shunned on the ASA firewall. Unfortunately, at least through the ASDM application, there is no way to view shunned devices easily or even to unblock them. The events do show in the logs, but we must use CLI or we have to reboot the ASA to get that host restored again, or changing the IP of that device. So that's why we don't recommend enabling scanning for threat detection, and this will not be shown in any of our video series to illustrate that. Another one is the new NAT changes for the ASA starting with version 8.4. So this is also kind of like a dislike, as this makes the NAT configuration more complicated than it really needs to be. NAT implementation before was much more cleaner and simplified compared to the direction Cisco thinks NAT needs to go with how it is configured. Another dislike is with SSL VPN Wizard. When we actually configure that, there's one important aspect that is missing, and I'm not sure why that's missing exactly. The VPN wizards are great, but for creating an SSL VPN through the wizard, it does not include split tunneling, and to configure that we need to do some additional steps manually outside of the wizard itself. Now luckily we will show you these additional steps that are needed in our video series. And last, we talked about AnyConnect, the SSL VPN solution on the ASA firewalls, and with the additional cost to expect. So this is considered as another dislike, not with the ASDM, but with the ASA itself, because more practical deployments are still using IPsec for site and client-based connections without the additional costs that are needed. So just keep some of these considerations in mind when working with the ASDM and the ASA firewall directly. Next, let's talk about some of the ways the Cisco ASA firewall appliance can be deployed within the network. Here are 3 ways the Cisco ASA firewall can be deployed within the network. We will discuss each of these options in the next set of slides. The first deployment method is the most commonly used since the beginning of firewalls and is still used today, mainly because it's more simplified and companies can physically see the security separation between the different networks. Here we see the firewall with 4 physical interfaces. One for the WAN interface connecting to the internet, the untrusted network, and the opposite, another interface connected into the LAN or the trusted network that we want to protect. Other networks are attached, which may include a guest network for guest users and a DMZ network where public-facing servers exist. This is also called routed mode because the ASA is routing these 4 networks and the IP for these networks are configured directly on the ASA. The caveat for this option, which is fairly obvious, is that a security engineer using more interfaces over time will quickly run out of ports on the firewall appliance. Another deployment option operating in routed mode is using 802.1q instead of multiple physical interfaces for each network. Doing this means that we have a single interface connected to the LAN. Each network is configured as a VLAN, extended as a VLAN tag up to the ASA firewall. This deployment option is recommended if the ASA can support the number of VLANs needed based on its model and basically if it is running the Security Plus bundle. This is the deployment option that we will actually be configuring in our video series. The deployment in transparent mode operates almost unseen to other devices. Let's provide a practical example to show how using transparent mode can be valuable with minimal changes to the devices on the network. So let's say that we have an existing network with IP addresses already assigned to servers, switches, and even routers. These could be public IP addresses, but our example is using private IP addresses. Here the network is 192.168.10.0. We have a server that's using .10 and our router is using .1, the default gateway for the server. Now let's assume we want to apply firewall services to this network. Well, simple. We will configure the ASA firewall in transparent mode, which operates in layer 2. It is placed in between the router and the LAN where the servers exist. So no readdressing is required, and we can quickly provide security protection to the LAN or to our server farm. Network design. Let's talk about some ways of how the Cisco ASA firewall can be designed to provide network security. So these are the basic steps required for building an ASA design. Number 1, first understand the performance requirements. Find out the data path that could travel through the ASA, such as the internet to the LAN and vice versa. Determine the bandwidth that is used and the lowest possible bandwidth along that path. Use this throughput as the performance needed with the ASA firewall in question. Number 2, determine the business size of the network, whether it is a small, SMB, medium, or a large enterprise network. Third, determine what security zones will be configured on the firewall, such as an outside, an inside, a guest, or a DMZ security zone. Determine what services are required on the firewall besides stateful firewall services. This includes site VPNs, client VPNs, IPS to even content security services. If client VPN services are needed, then determine if it will be IPsec or SSL VPN. Remember, there's a higher cost association with SSL VPN. Number 5, with the services that will be used, determine and take note of the licensing that is required with the ASA firewall, which could be additional costs. And last, choose the ASA firewall model that aligns with these requirements. An ASA model that aligns with the firewall and VPN performance based on the lowest throughput along the data path, the business size, and the security zones based on the physical interfaces or VLAN tagging will be used. The ASA that supports the services needed along with the required licensing where applicable. So just follow these steps for determining the ASA firewall that should be used on the network. Let's discuss what configuration we will focus on in our video series using the ASDM. We will use our ASA firewall in routed mode and support 802.1q with our network. We'll be using only one physical interface into our LAN core with 3 VLAN tags. You will see those VLAN tags listed and the purpose for those networks. One will be for our LAN, our guest users, and another for our DMZ. These VLANs are configured within our network where needed. As we mentioned in the beginning of this presentation video, this particular series is focused on showing you how to deploy and design the Cisco ASA firewall using only the ASDM application. This is the network diagram for our design used for the video labs. This includes the hardware and subnet information that will be used. For the topology, we have our Cisco ASA 5505 connected to the internet edge using Comcast as the provider. On the back end, it will connect into our LAN core. 802.1q will be configured between the ASA and the core switch for the VLANs listed. We will have DMZ servers within our DMZ VLAN, and our guest network will be in the guest VLAN routed up to the firewall. Also keep in mind that a full-size version of this diagram will be present in your package, so definitely check that out while we configure the ASA firewall. We'll show you the base configuration needed in terms of the initial access of the ASA firewall and configuring our interfaces with different VLAN tags. We will upgrade the firewall OS, including the ASDM software. We will configure NAT in different ways to show you how it can be used in practical environments. This will include PAT, NAT port redirect, and even one-to-one NAT configurations. For the PAT configuration in our environment, we will translate the entire guest network, the subnet, to use the IP address on the WAN interface for communicating with the internet. We will configure a network object for this. For the network port redirect, we will configure TCP port 80 between our DMZ server at 10.67.182.11, mapped to the public IP on our WAN interface. This will also be configured as a network object. We will configure another NAT port redirect, but with more ports to forward. We will configure TCP ports 3389 and 8080 between our DMZ server at 10.67.182.12, mapped to the public IP on our WAN interface. This will require configuring a NAT rule or twice NAT on the ASA firewall. For the static NATs, we will configure our DMZ server at 10.67.182.13 to be mapped to a new public IP that will be shown in the video lab. This will be configured as a network object. We will show you the firewall policy configuration, which includes using object groups based on what we will configure with our NAT. We will configure a site-based VPN to a remote site. We will configure remote access using IPsec and SSL VPN. Our users will be logging in using their AD credentials, so we will show you how to integrate our ASA firewall with Active Directory using LDAP. Our SSL VPN configuration will also include how to customize the SSL VPN portal page. We will configure split tunneling and show you how to view the VPN sessions, including how you can manually log out VPN users. Other network security configuration will include policing or rate limiting. We will enable basic application inspection for all interfaces, which is called the global interface on the ASA. We will disable proxy ARP for all interfaces and enable anti-spoofing on the WAN-facing interface in our design. We will show you many maintenance, monitoring, and troubleshooting methods that will include some of the following. We'll show you the dashboard on the ASDM page and what information it can provide. How to use the packet tracer in doing a packet capture on the ASDM for traffic flow between two networks.